Okay, so we are in Statistical Rethinking, second edition. We are in Chapter 8, and we're starting the hard questions, and so we'll go through 8H1 as well as 8H2. They both deal with the same data set. So we're returning to the data set called tulips, and we are going to modify the model given earlier in the chapter. Okay, and in fact, that model, let's just look at it real quick. That model is right here, okay? And importantly, what we're going to do is we're going to add the variable, the predictor variable, bed. Okay, so these were tulips planted in different beds, and so we're going to add bed as a predictor variable. It's not currently in there, okay? So let's just do that. So first I'm loading the data set, and then I'm standardizing and centering the predictor variables, okay, just because this is what was done earlier in the chapter. And then let's look at the variable bed in the data set here, okay? And so we see that it's just a bunch of, it's a factor variable, and so it has levels A, B, and C. So we have 3 beds, bed A, bed B, bed C. Okay? So we need to get this into the model. And it says that we can do this in a couple of ways. We can either construct dummy variables or an index variable. Okay, so I'm going to use index variable, and in general, I will usually use index variables. And there's a couple of reasons that are explained in the book, but I'll just briefly give them here. So remember that with a dummy variable, well, actually, let's make the dummy variable real quick so you can see. Maybe this will make a little bit more sense. So one way that you could make these dummy variables is just with this command right here. So model matrix, and then I'm using this little tilde d bed. Okay, if I let me mark this out real quick. So when I do this, I get this. Okay, so I get an indicator variable for bed B and bed C. Okay, and so these are my indicator variables, and then I have an intercept here. Okay, but I don't really care about the intercept if I'm going to add this to my data set. So that's why I'm omitting that first column. Okay, and so again, we have dummy variables for B and C and not for A in this case. And again, the reason is because when you use dummy variables, you omit one of the levels of the factor, right? It becomes the de facto comparison for the other levels of that factor. Okay, so that's how you would do it. I'm not going to do that. So why? Well, one of the reasons is because when we put this into, if we were to put this into the model and we get a posterior, notice then that we don't get a posterior for the omitted level, right? We don't have a posterior for A. It just gets sucked up into the intercept of the model, okay? And that can make comparisons kind of difficult, right? So if we want to look at the contrast between, say, bed B and bed A, well, we never estimated A, right? And so because of that, we don't have a variance on A. And so it seems as though our confidence in A is very, very high, in fact, infinitely high, because there's no variance associated with it, right? But that's an improper inference. And also when we don't do dummy variables, but instead we do this indexing, we get thrown in for free pooled estimates of the levels, okay? And so this helps normalize our inferences, but I won't talk too much more about that. Okay, so let's just get bed into the model, okay? So it's the same model that I showed you a little bit ago, but now my intercept, I'm indexing over bed, okay? So that's here and that's here, okay? And so let's just run that. Okay, so we've ran it, and now what we have is our posterior summary here, and instead of one entry for the intercept, we have 3, right? Because each bed now has its own intercept. That's what we've done here, okay? And so what it looks like is that that bed 1 is not doing as well as beds 2 and 3 for whatever reason. It just happens to be that way, okay? So that's fine. All right. Now in part 2, or in question 8H2, we want to compare the model that we just ran from question 8H1 to a model that omits bed. Well, the model that omits bed is right here. It's the one given in the chapter. Okay, and what do we infer from the comparison? And can you reconcile the WAIC results with the posterior distribution of the bed coefficients? Okay, so let's run this and look at the outcome of the no bed example. Okay, and so this is our posterior summary here. Okay, and that's all fine. And we could examine this compared to this a little bit more closely. They're pretty similar, except for, of course, the no bed example doesn't have intercepts for each bed. It just has one intercept, which is about midway between between the three intercepts for the bed model. Okay. But now let's compare these with WAIC, and I'm also going to use PSIS just because. Okay, so let's run this. Okay, so there's a couple things to notice right away. It's frustrating often when one method, WAIC, orders or ranks the models differently than PSIS. Okay, so that just is what it is. These are two different ways of trying to estimate out-of-sample predictive accuracy of the models, and sometimes they give different answers. That doesn't mean that we should discard one of them. There's information in the disagreement there, okay? So it just remains something of an unsettled question. But the next thing to notice is that the difference between the models, whether we're using WAIC or PSIS, is very small. So if I go to DWAIC, which is the difference between the models in terms of WAIC, or if I go to DPSIS, notice that that value given for the worse model is much smaller than the standard error of that difference, right? So in other words, both WAIC and PSIS are ranking the two models to be actually very, very similar, even though they give them different rankings. Okay. So what does that tell us? Okay. Well, what it's telling us. So the fact that when we include bed or when we don't include bed, we get very, very similar predictive accuracy. Apparently, then, what that is telling us is that including bed in our model isn't doing much by way of predictive accuracy. At least our predicted accuracy. Okay. So that's one thing. Now, that can be a little bit confusing, I think, especially if you look at the posterior from this no-bed model, okay? Because we see that these coefficients are all well above 0, right? They are reliably above 0. And so we might take that to mean, using bed in the model is important, right? Because there is a clear signal coming from the posterior distribution, but that's the wrong way to think about that. Okay, the way that we want to think about this is, are the levels very, very different from one another? Because if they're not, it might be better just to have one intercept in there, right? So instead of partitioning by bed, maybe bed isn't that important, and we just collapse all that into a single intercept. Okay, and so apparently what this is telling us. Again, the closeness of the models in terms of WAIC or PSIS, is that having bed in the model is not that important, and that is evidenced by the fact that our estimates of the bed intercepts are pretty close. Now, like I said already, bed 1 is doing worse than beds 2 and 3. Okay. And so there is some difference, and maybe that is the difference that is being detected here by WAIC, okay? But apparently the difference that is making, right, the difference in bed 1 compared to beds 2 and 3, the difference that is making in terms of predictive accuracy is apparently not very much, again, according to WAIC. Okay, so I think we'll call that good, and I'll see you next time.